Quadrature.
F50 for sine wave for in-phase.
And 100 కి దగ్గర రావాలి. సెంటర్ 100 కి పెట్టు. Try.
Peak of FPT is at 100 kHz, so the frequency of this sine wave is 100 kHz. It's the same for the cos input also, the cos output also. At 100 kHz we have a peak. Phase difference of 90 between these two output signals of the oscillator. For the mixer circuit, this is the input voltage that is given at the source. It has a amplitude of 300 mV and a frequency of 99 kHz, roughly shown here. This is the V bias given at gate of MOSFET for switch. The circuit is as follows. This is our oscillator. This is the MOSFET switch part. Since our output of the MOSFET, the switch is really low, observing it with oscilloscope is really a tough job, because it is nearly around 50 to 100 millivolts, which is almost equivalent to the noise amplitude. So noise is equally dominating the output signal. So we are just amplifying it using a non-inverting amplifier here, and then passing it to low pass filters to observe the output more clearly. Now these are the output voltages at a mixer which is amplified. These are the outputs of the mixer circuit. This is the sine part and the cos part of the two outputs of both the mixers. Now the FFTs of both the outputs. The sine wave has this is a combination of two frequencies. The output of mixer is a combination of two frequencies. One is at f1 minus f2 and the other is f1 plus f2, where f1 and f2 are the frequencies of input to mixer and output from oscillator. Sorry. This is f1 minus f2, where the peak is observed at 1 kilohertz, that is frequency of oscillator minus frequency of input to MOS switch. The peak is observed slightly greater than 1 kilohertz, because the output from oscillator is not exactly 100 kilohertz, but 100.3 and somewhat closer to that. So our peak is observed at 1.3 kilohertz, which is the difference of both the frequencies. Our other peak is observed at the frequency of f1 plus f2, which is 99 plus 100 kilohertz, which is approximately 199 kilohertz, but frequency is slightly greater than 199 because of the imperfection of the oscillator output frequency. Now for the cos input, we get the same FFT because it also consists of the same frequencies, but just the phase is different from that of the sine. This is for the 199 kilohertz. And this is for the 1 kilohertz. We can observe that these outputs of the mixer are also at the phase difference of 90 degrees. Now getting to the LPF, the output of the mixer which is amplified is passed to LPF field, and the output is as follows. The lower frequency part, which is f1 minus f2, is only observed in the output, whereas the other frequency is the component of other frequency is completely attenuated, but you can still observe slight parts of it when you zoom into it. These slight peaks are the components of high frequency, which are reduced when compared to the previous output which you observed through the mixer. Now for the FFT of this graph, this is the peak at 1 kilohertz, which is almost the same as we observed from the earlier part, whereas the other frequency, which is f1 plus f2, that is around 199 kilohertz, is highly attenuated. Earlier the peak was almost closer to that of the 100 kilohertz part, 1 kilohertz, but now it is reduced significantly. This is the amplitude of FFT at around 199 kilohertz, but the amplitude is at 200 because of some imperfection. Similarly, doing the same for sine, for the cos input. Same goes for the cos input. The amplitude at 1 kilohertz is almost the same, whereas that at 199 kilohertz is highly attenuated.